lesson 7.5 is on exponential functions. In this lesson, you will learn to graph exponential functions and identify data that display exponential behavior. Vocabulary is exponential function, exponential growth function, and exponential decay function. Okay, so an exponential function is a function that can be described by any equation of the form y equals ab to the x, where a is not 0, and b is greater than 0, and b is not 1. Okay, so just note in each of these equations, exponential functions, only the b is raised to the power. So this would be like 2 times 3 to the x. This is like 1 times 4 to the x. And this is like 1 times 1/2 to the x. So in this one here, your a would be 2, your b would be 3. Here a is 1, b is 4, and a is 1, and b is 1/2. Okay, so we want to graph a function when a is greater than 0 and when b is greater than 1. So if I want to look at the graph of y equals 4 to the x, what I'm going to start by doing is making a table of values for x and y. So I'm going to start with like -3, -2, -1, 0, 1, and 2. And we'll see what we get when I put in these things to start. So I'm putting those in for x. So 4 to the -3 is -0.015625. If I do 4 to the -2, I get, sorry, that's not negative, that's positive, 0.0625. 4 to the -1 is 0.25. 4 to the 0, anything to the power of 0 is 1. 4 to the first is 4, and 4 to the second power, since 4 squared is 16. So these are the things I want to be graphing. So I'm going to make a table of values. Oops. Okay. So I'm going to take this, and I want to graph those points. Sorry, it's hard to draw on this. So -3 is like super little, like in there. -2 is still super little. -1 is about 1/4 of the way up. 1 at 0, it's 1. So that's there. And 1, it's at 4. And 2, it's at 16. So 4, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay, so this is going to be, I'm just going to draw a smooth curve, or try to draw a smooth curve, going through each of my points. Like I said, it's really hard to draw on this, but that's basically what it's going to look like. So you graph it by making a table of values and plotting the points and draw a nice smooth curve going through it. And the second part of this, it says to find the y-intercept and state the domain and range. So my y-intercept, that's where it crosses my y-axis. So in this, right there is my y-intercept. So my y-intercept is 0, 1. And then it wants the domain. So domain values of x are accounted for. So this graph here is going to keep going and going and going and going along that way. And it's also going to keep going up. So my domain, no matter how far I go this way on x or how far I go that way on x, I'm always going to be able to find a value of the function. So my domain is going to be all real numbers. Okay, so domain, you want to think about x. Where do you have values for x? And then range talks about y. So I want to know where I have y values. I have y values going all the way up because, again, this keeps going. But this thing here kind of levels off. It keeps going along the axis. It doesn't cross over it. So my y values are only going to be positive numbers. So y is going to be greater than 0. Because I don't have anything for y anywhere below there. I have no y values in there. No point I could ever put on that line will have a y value less than 0. Okay? So there's a nicer looking graph, nicer than the one I drew. And so we want to be able to look at a graph and determine a value. So in this one, it tells us to use the graph to determine the approximate value of 4 to the 1. So since this is x is the exponent, that means this is x is 1.5. So I want to know what y is when x is 1.5. So I go on my graph and I figure out where 1.5 is. It's there. So I go up, 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 up until I get to a point on the graph. And then I look over and I see what the y value is there. So 1, 2, 3, 4, 5, 6, 7, 8. So this is going to be 8. Y equals 8. Okay, and if we just want to check it by putting into the calculator 4 to the 1.5, see if you get 8. So when I do that, 4 to the 1.5, I do get 8. Okay, so then I would say that this is about 8. Okay, you guys can try these on your own. Okay, what if we have a greater than 0 and b is between 0 and 1? So basically, our b is a fraction less than 1, but still greater than 0. So in our case here, it's 1/4. I want to find the y-intercept and state domain and range. So we're going to do the same thing we did in the last one. We're going to make a table of values, x and y, and I'm just going to plug in points. So if I start with -2, -1, 0, 1, 2, and 3, when I plug those things in, so 1/4, so 0.25 to the -2 gives me 16. 0.25 to the -1 is 4. 0 to anything to the power of 0, remember, is just 1. So this is 1. If I raise anything to the first power, it's whatever it is, that's 1/4. To the 1/2, it's going to be raising 1 and 4 to the second power, so it's going to be 1/16. And 3, that's going to be 1/64. Maybe not. There it is. Okay. So these are the points that I want to be graphing. So I'm going to, again, make my axes. So here's my y-axis, or an attempt at the y-axis, and my x-axis. Okay, and I want to find -2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Let's go by 2s. 2, 4, 6, 8, 10, 12, 14, 16. Okay, and then -1, 4. So going by 2s, that would be there. 0, 1 would be here. 1, 1/4 would be pretty low. And then it gets even lower and lower as you go. And then you want to just draw a smooth curve that goes through that. Hopefully your guys' smooth curves can be so much nicer than mine. Well, you kind of get the idea. All right, so again, looking at this, I want to find the domain and range. So domain, anywhere I go along the x-axis, there's going to be a blue line somewhere if I will go straight up and down, because this is just going to keep going and going that way. Even though you can't see it, eventually it's going to be over there. It's not going to be that quickly. But anyway, so your domain is still going to be all real numbers. Okay, and the range, remember, up and down. So the range, because all of my blue is above the x-axis, I only have y values that are greater than 0. So y is going to be greater than 0. Okay. And if I want to use this to determine what value of this 1/4 to the negative 1.5, I'm going to go to negative 1.5 as my x on my x-axis. That's going to be about here. And I want to go up and see what the y value is there. So that looks about there. And if I go over, 1, 2, 3, 4, 5, 6, 7. I get about 7. So we just want to plug it in and see if we're close. So if I do 1/4 to the negative 1.5, I get 8. So we were close. 1, 2, 3, 4, 5, 6, 7. Yeah. I mean, it's not going to be exact because it says approximate. So, okay, you guys try. Okay, so if you notice, the two that we graphed, they both had the graph going one way and the other way. One was increasing and the other one was increasing. So this one, this first one, is an increasing function. We call it an exponential growth. So this thing grows as it goes from left to right. And then we have exponential decay. That one decreases as you go from left to right. Okay, so some people say that the value of a new car decreases as soon as it is driven off the dealer's lot. The function v equals 25,000 times 0.82 to the t miles to this depreciation of the value of a new car that originally cost $25,000. V represents the value of the car and represents time in years from the time the car was purchased. Graph the function what values of v and t are meaningful in the function. Okay, so for this one, we're actually just going to use a graphing calculator to do it. So I'm going to show you on an online one right now, and then in class we will look at the other ones. So my function, 25,000.82 to the t. So we're just going to take a detour into here. So v, we're going to do 25,000 times, okay, and then it was 0.82, and then we're raising it. Oh, I have Spanish keyboard on hand. Okay, raising it to the x, I guess we'll say. Okay, and so if I want to graph this, I can say v equals, and we can call this t if we want to. Why is not graphing? Oh, it's over there. Okay, so you can just play with the scrolling thingy-majiggered. So if we're looking at this, this is going to be the graph. So we were talking about starting at 25,000. So I want to start this. I want to go up to 25,000 at least. So maybe we'll do 30,000 with a step of 5,000. And then the x, we don't have to be as big. We can do maybe from -10 to 10. And now that looks more like the graph that we were seeing before. So they want to know this important points. So the important points are generally where it's going to cross the y-axis. So looking at this, 0, 25,000 is where we're looking. And yeah. Okay. So we want to use the graphing calculator. What values of v and t are meaningful in the function? So the next part says, what is the value of the car after 5 years? To do this one, all we're going to do is plug in 5 into our function for t. So v equals 25,000 times 0.82 to the t. So we're just going to put into that 25,000 times 0.82 to the fifth, and then put it in your calculator and solve. So 0.82 to the fifth, and then multiply that by 25,000, and you should get 9268.5-ish. So, well, because we're talking about money, we can say 50. So it'll be about $9,268.50 after 5 years is how much that car is going to be worth. Okay, you guys try this one. You may use a calculator. It should look like that. Okay, and try this. Okay, we want to be able to identify if it's exponential. So the ones that we have exponential are the functions where you have like a number, a, b to the x equals y. So something that's exponential will have a constant being multiplied by each of these. So if there's a constant ratio, so if I take 10, what do I have to multiply 10 by to get to 25? So I'm going to do 25 divided by 10, and I get 2.5. So that is the constant being multiplied by 10 to get there. And let's see if it's the same for the other one. So 62.5 divided by 25 is also 2.5. And if we were to do it here, we would also get that same thing. So 2.5. The other option that you have in order to see if this is exponential, so because all of this is the same, it is exponential. The other way you can do it is you can graph it. So you can say 0, 10 is here. 20, or 10, 25 is like here. 20, 62 is like here, and 30 would be like that. You would see that this shape looks to be exponential if you were to graph the points. So those are two ways you can tell if something is exponential. Okay, you guys check this one, see if that's exponential, and you should get that it is. Okay, and that's the end of this section.